Hello, my name is Michael Anderson, and I'm here to present an open source method of image cytometry in dorsal root ganglion tissue with immunofluorescence. All right, so to begin, let's take a look at kind of the heart of the processing power. This is the schematic of the algorithm, and it's divided in between run 1 and run 2. Run 2 is utilizing DAPI, which is a pan-neuronal or pan-nuclear marker, labeling the nuclei of all cells in the field of view. However, it is really Neuen that is the magic behind this system. Neuen identifies the cytoplasm of the cell of interest, what are neurons in my case. And so this was very important to thoroughly evaluate the expression pattern of Neuen in terms of the algorithm, to make sure that the algorithm could process the range, the variability of the expression of Neuen with immunofluorescence. So to do this, we first took a look at Neuen expression in DRG neurons in an acute inflammatory model that looked at the peak swelling point of inflammation in the paw, the hind paw of a rat. So we undertook the study to really, see between conditions, between naive and inflammatory conditions, where there are changes between the same size populations, such as small versus small, medium versus medium, or large versus large. And thankfully, in the cytoplasm or the nucleus, now we're primarily interested, actually solely interested in the cytoplasmic expression pattern. But there were no differences in any groups except for the CGRP positive groups for cytoplasm and nucleus. And even in these, there were no direct differences between the same size populations. So this shows us that CGRP positive, CGRP negative, there are no differences within the same size populations, which is very important for the accuracy of the algorithm. So now that we, and this research is actually in review, this is the other part. This is my aim 2. This is actually looking at the algorithm itself. So this is the heart of the poster that I'm presenting, and it's currently in review with analytical biochemistry. And it was great news, that Neuen's not changing too much, certainly within the bounds that the algorithm can process everything. So this is kind of a generic image that I put together. This is not what the program or the plugin looks like. This is part of the getting the thing published. They wanted a graphical abstract. But this process offers a camera exposure optimization, which is really important whenever, since the algorithm is processing a lot of these things based on pixel intensity. It's very efficient. It can save many hours. It's low error. It's got a 93.8% accuracy. And of course, this really standardizes quantification and the harvesting of data within labs and even between collaborative labs. And this is just an illustration showing the low error. And so it's with the camera exposure optimization, it's right down there at 6%. Alrighty, let's take a look at this in action real quickly. Okay, so this is actually the folder system that is used by the software. I'm gonna go ahead and jump up a little bit further. This is looking at the script itself. So this is it's over 2,000 lines, a lot of processing power. And let's go ahead and take a look at the thing in action. So here to the right, you're actually seeing the log window of all of the processing. To the left here, you are seeing all of the resulting, processing that you're seeing. So it's kind of going through and processing each one. It's got a pretty big folder system. However, after each experiment, you actually go in and just delete that folder system, and then you can copy over a fresh empty version of those, and you can just run it again very quickly. So now let's take a look at the results of this. So these are actually the masks based on Neuen, and you can tell that between those cells they were automatically divided or segmented. These are the nuclei that were qualified as neuronal based on the Neuen marker. And then of course here I'm just showing how to easily repeat this this algorithmic processing. You basically just take all of those, once you've copied them to different folders, you delete them, and then you copy in these the empty folders, which the algorithm, once you populate the Nguyen and DAPI images, then it's able to run again. Alrighty, well, I want to thank Dr. Miller and everybody in my lab. I don't have a photo of Kirsten, but she actually helped me. She's part of the acknowledgements of this manuscript. She helped kind of use it and give me some ideas on making it smoother. And again, I want to thank Dr. Miller very much for all of his help. He's been invaluable in supporting all of my ideas, and I couldn't have done this without him. I want to thank my lab, and alrighty, enjoy my poster. Thank you for your time.